Hello, my name is Alex Gonzalez, and today I'm going to be working with arrays. I have a two dimensions arrays as the output that is going to have the snail pattern, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So if you see, the output has to be like a snail format. And the input is going to be a single dimension array with the numbers 1 to 16. Everything's already ordered. There is no need to order it or create another array or whatever. So as it's a tradition now, it's, like in my previous videos, I'm going to share something personal that this time I'm going to do it professionally. Even when arrays are very useful and are powerful, I honestly, I've never used any of those in my professional career. Probably because of the type of problems that I've been working with, which are security solutions or inside the Linux kernel or inside the the Windows kernel, and some other type of applications. I've done a lot of things with Python and the dictionaries and bash arrays or so, but not that much with pure arrays. So I know that most of the interviews are looking into understanding if the person has the skills to manipulate arrays and this and that. So that's why I'm looking into these kind of problems now. Going back to this problem, I can tell you that this was my favorite problem when I was interviewing as well in the past. And I have not done it in a while. Probably I used it for like 10 interviews, and then for another 20 interviews I didn't use this problem anymore. And the fastest person that was able to solved it in 40 minutes. I spent 1 hour and 10 minutes solving it the first time, like 10 years ago. And recently I did 1 hour and 20, the last week. So I'm not looking at my notes or anything, and not trying to go beyond or I'm not trying to cheat here. So I'm just trying to show you the way I think when I'm trying to solve a problem such as this Snail. I'm not trying to cheat, that's for sure. That's very true. But as I said, I did resolve it last week, so kind of I remember the logic that I used, and I'm gonna share that with you and implement it the way that I thought. And I think it's a good solution, probably not the best one. I haven't figured out another one, so I'm gonna go ahead and use this one. So the problem here states that I need to go through a snail pattern, and that's not kind of something that you can predict. So in order to move your indexes to populate these values in the proper way, I created kind of list of moves that you have to do on the axis and the y axis. So I'm using x as the row and y as the column. Probably we should use that. So let's think that you are in the position 0, 0, because that's where you're going to start usually on your loops. If you're in the 0, 0 position, you already are here, right? So from here, the first time on columns, you need to move 3 times. So plus 3, I want to say plus because I'm moving to the right, plus 3 columns. And then from here, you need to go plus 3 rows. Oh, I had something in my keyboard. Plus 3 rows. So let's say R and C for columns. And then we're in this position at this moment. So we need to move on the columns minus 3. Oh, I see why now. Minus 3 columns, right? So we're in this position, and then we need to move 1, 2, in the rows. So -2 rows. And then from here we need to go +2 columns, and then +1 from here, +1 row to this position, +1 row. And then -1 column, right? And then that's it. That's what I'm gonna do at the very end. So how can I translate this to something that is useful? What I can say is that my columns, I'm gonna translate it to an array of elements. That is gonna be equal to, and I'm just trying to put it in a way that I understand, that's understandable. So it's +3. So in the columns is 3, right? I'm gonna add a comma, and then I'm gonna add here a row. Elements is 4 elements because this is a 4x4. I forgot to mention that. It's equal to 3, right? So I'm adding that in the first iteration. I'm gonna look into moving 3 columns positive and 3 rows in 3 rows later. And then on the second iteration, I'm gonna move -3 columns. So -3 here, right? And -2 rows. -2 rows. So here I am. And then it's +2 columns. Well, I don't need to do the 2, right? And then 1 row. And then -1 column and 0 because there is nothing else there. And that's what I'm looking for here. This is gonna be my rules Let me see, give me 1 second because I guess I have not done something important here. Yes, interesting. I'm guessing that I have it open somewhere else via Snail. Okay, so here we are. Everything is fine. So those are gonna be my rules to move through these conditionals, let's say, and then I'm gonna be populating all of these elements there. So what I'm gonna need to do is to do a loop through int elements. Let's do it here. Int values index. I'm gonna need an index for these elements, and I'm gonna need an index for the column row, right? So this is let's name this the rules index. I think that makes sense. Int rules index equals to 0. So I'm gonna iterate through rules index lower than elements, and then rules index is equal to, well, plus. Okay, so what I'm doing here is just saying that I'm going to iterate through the rules, right? The number of times that it's expressed here, and then I have an index for this, and I should have as well an index for the column and an index for the row, because the index of each of those are going to be moving in a positive way and a negative way. So I need more ci is equal to 0. That's going to be the beginning, and then row index equals to 0. So everything is initialized to 0 at this moment, which means that oh, and also I'm gonna need the Snail array that is gonna be a 2 dimensions array that is gonna be the output. And where I'm going to be sending all the data. I think that's it for now. Okay, so what I'm going to need to do is first move. Okay, so I'm going to be moving to the right or to the left on y. Since y is going to be my first move, because it goes from +3, I'm going to start validating that the value is positive. So let's say if column rules E equals to, or is greater than 0, greater or equal to 0, then what I'm gonna do is to move the number of times that rules E has. So for column I is less than the value the value of the column then ci, the index of the column, I'm gonna increment it. So with this condition, I'm gonna so at the beginning I know that ci is 0, so the position is 0, and with this conditional, if it's lower, because C rules I, the index is 3, so it's lower, yes, so it's gonna move 3 times, because this is gonna, at some point, it's already 3, of course, and the condition is gonna get there. So at this point I can say, because it's 0 here and everything is 0, so I can add into my Snail of ci and ri, which is gonna be x, is gonna be the row, so ri and ci, it's gonna be the value of this, which is values of values E, right? And since I already used values E, I can do values E plus plus. So that's the case where I'm just populating at this point from 0 to 3, because the value of this is 0 until 3. It's going to populate 1, 2, 3, 4, which are the first 4 elements. Yeah, I think so. So in a similar way, if it's not greater than 0, the rules I. So the rules I, if for example is going to be in the case of the columns is going to be -3, we need to do something similar for Ci greater, yeah, because it's gonna go into minus minus, so we need to validate that it's gonna be positive. So yeah, C rules I rules I. Yeah. Then I'm gonna do Ci minus minus. And in the same way, I'm gonna say Snail, pretty much the same code, because I'm moving the indexes the right way. Ci equals to values I and values I plus plus. So if it's a negative number, like I'm in the 7, I'm gonna move to the left, then it's gonna come here, and then the 7, and I'm gonna move to the left, is gonna become here and say Ci, which is the column number 3, is greater than the -3. Yes, so I'm gonna need to reduce this. But also it cannot get to 0, I mean in a positive way, so I need to validate here. And yeah, Ci is greater than 0. Yeah, because it cannot get to a negative number, because the index cannot be negative. Of course, we don't have that problem here because this is going to the positives. So yeah, okay, here I have a typo here. I think that's it. So I'm moving this. This is only to move, or this loop, not the loop. The condition is just to work with the columns. Now we need to do, or I need to do something similar with the rows. So rows need to go through rules AE, and then rows AE has to go through rows AE, rows. This is okay because it's the same thing. Values AE, values plus plus, else Rosie has to. This is the same, this is the same, this is the same. I think I'm missing something here because okay, that makes sense. That makes sense. The things that I'm validating here. So first of all, I'm gonna move because I know that the first move is gonna be to the right, and then the second moment is gonna be through the to the bottom. So it's gonna be the rows, and then it's gonna move to the next rules, and it's gonna perform whatever comes next here. So -3, -2. So for example, if it is -2, we're here, and this -2 is going to be performed to move here and here. So it's going to come here. Rows is greater than, yeah. But there is a moment where those two are going to head to 0 because we're doing the minus minus and minus minus. There is a risk that both are going to be 0. Okay. I don't know. Okay, so let's display the matrix. Matrix has the column and the rows, but anyway, for int I equal to 0, I less than lms I plus plus, for j equals int equals to 0, j less than lms j plus plus plus. So print f let's do it well. Print f plus percentage d. E J I can do that, but I can also print the okay, let's a little bit confused with the thing that is it might go to zeros. I'm thinking about there might be a mistake over here. Anyway, so I'm gonna print this. I'm gonna try it out like this. So let's cc snail output snail. Okay, snail lms. Oh, lms. It's lms. 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 The 32. Yeah. And then 45. Let's see. Yeah, because I copy pasted. Okay, it's there, Snail. So it's giving us 13, 14, 15 for. And what we're looking is for 13, 14, 15 for. Okay, so there is an issue here, as you can see. This is not the order that I'm looking for, and actually I should present it in a more friendly way. But to start with, I have a value here that is wrong. So for the 0. I want to, I think, well, let's do this. If j, which is a column, if j it's equal to 3, then printf just like that. Yeah, it's going to be a little bit more friendly because I have the vision of the snail. So everything is a mess. I don't even see the number 1 or the number 2. So let's see what's the problem over here. I'm supposed to have here the first value on 0, 0 of values I incremented it. Ci, I am incrementing it, and Ri, I'm incrementing and decrementing it. Rules I, it's as well being incremented and not decremented. So printf 0, 0, I don't know. Snail Ri Ci. So the first time it's nothing, then 1, 2, 3, 13, 14. That's kind of weird. The first time should be at least okay, so I want to add the value and also the RICI. So 0, 0 is 1, which is good. 0, 1 is 2. 0, 3. 0, 2 is 3, which is good. And the 0, 3 it didn't arrive to the 03. Why didn't arrive to the 03? Am I missing the... Okay, so I'm gonna use the same thing here because that's gonna help me to understand where we are for all the values. Oh, good. So 0, 0 is 1, 0, 1 is 2, 0, 2 is 3, and 0, 3 is 4. And that's what I want, right? Because these are 0, 1, 0, 2, 0, 3, 0, 4. Then I'm moving to the row, which I'm incrementing the rows, which is 1, 3, and that's fine, it's 5, perfect. Then it's 2, 3, and then it's 6, and 3, 3 is 7. 3, 3 is 7. Yes, we're here. So it's getting there. Number 8 is going to be 3, 2. 3, 2. 3, 2, yeah. Because I'm going lower now on the columns. 3, 1 is 9, and 3, 0 is 10. 3, 0 is 10, perfect. And then 2, 0 is 11. 2, 0 is 11. Then 1, 0, I'm decrementing this one. 1, 0 is 12. 1, 0 is 12. And then I'm gonna need to go to this, which is gonna be 1, 1. And it goes to 0, 0. And this is supposed to be 1, 1. 0, 0, as you can see, it's supposed to be 1, but 0, 0 in the print, it went here. And that's what I was thinking, sort of, because the numbers can get to 0. I mean, when I'm doing the minus minus, there was a risk to get or to head to 0. So I'm guessing that I should not let them get to 0. For example, if I should not let them get to 0 again. If they get to 0, I just increment them by 1. That might work probably as a hack. This is okay. This is different than the previous week. Okay, so I'm finding a different type of implementation. Anyway, the point that I have here is that if xi is equal to 0, and both should get to 0, I'm guessing. And it's not x, it's the column. I mean, actually the row. The column, the x is the row. The column I is equal to 0. I can just increment it to 1, 1 because that's what I'm looking for, to have in the 1, 1 position this. I need this 1, 1. I mean, I'm gonna kind of cheat this kind of hack. I mean, yeah, sure. This is gonna take me to, because whenever these get to zero, and the first time is not gonna get to zero because the first time I'm already incrementing things or decrementing things, but at some point they're gonna reach to this 0, 0, and it's gonna give me what I need and restart the moves from the rules from there. Oh, well, anyway. Yeah, 13 now is in the 1, 1. 14 is in the 1, 2. 14 is in the 1, 2. Yeah. 15 is gonna be in the 2, 2. 15 is in the 1, 1. Fifteen is in the 1, 1. And 16 is not here. Well, this snail is starting looking good for now. Till here, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 is supposed to come here. 14. Then 15 and then 16, but I'm having trash here. So first of all, I'm not heading to the 16th element, but I mean, this did arrive to this place. So then the 13, the 13 is not moving well because I mean 13 is okay, but 14 is, it says that is 1 and 2. Here it's okay. I mean 13 is not shown here, but the 14 is in the right position here, but it's not supposed to be 1, 2. It's supposed to be 2, 2. 14 is supposed to be 2, 2. Yeah, well it's actually 1, 2, so it's all right. 14 is all right. 15 is not supposed to be 1, 1. Seems like I'm not moving in the right directions. So I'm going to check this again. 3, 3, 3, 2, 2, 1. So 3 in the column. 3 in the row. 1, 2, 3 in the row. 3 minus 3 in the column. Minus 2, 1, 2 in the row. Plus 2, 1, 2 in the column. And then 1 in the row. Which is true, but since I tricked it with the plus plus, let's see. Interesting. Okay. So yeah, there it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And it's what I was expecting, but yeah, I found a different way to solve this, but I'm tricking this. I mean, it's that, yeah, it's sort of cheating, but it's not, because it works, and if it works, don't touch it. That's the rule. In any case, this rule should not be 2, because if it's 2, it should move here, but since I did the play with the indexes, the 2 makes sense. Oh yeah, it's the 2 here. Yeah. So I was thinking in the wrong way. So it's gonna be plus 3, minus 3, minus 2, plus 2 plus 1 where am I losing it? I'm trying to validate and be comfortable with this, but I'm not really. I know that I'm tricking this because of the index that I move here, but so this is not valid, and somehow what I was thinking is that make this variable so I can manipulate any snail of any index, but that's not gonna be really successful because I need to as well create these rules based on some meta rules, let's say, or a pattern. But the pattern breaks here because I'm cheating with this. I mean, it's a hack. I'm not cheating, it's a hack. And I'm doing a hack as well here. And if I do 5 elements, this plus plus probably is going to require more than a plus 1. Probably is going to need a plus. Well, the logic says plus 2, but I don't know. I will need to try to implement a 5 and 5 and see how it behaves. But this is not. I mean, right now as it is, it's not going to work because first of all the rules. Anyway, the problem is there. The solution is here, and even if I'm not as happy, I don't remember how I did it the last time. Anyway, that's the solution. Yeah, I'm gonna do some other exercises with arrays and then try to come up with better or more logical solutions. Definitely the snail, that's probably why it was for many years my favorite problem, because it's tricky. It's really tricky, but it has a solution. And I found this based, I imagined this problem myself because when I was a kid there was a game, a plastic square thing with 15 numbers, and there was one space where you can move all the squares around and then do different patterns. And this was the impossible pattern to be ordered on that square. What is interesting is that it was really impossible when I was a kid, or I never could solve it. And probably now I see why we need to cheat. And when I was a kid as well as I was cheating, I was breaking it and then moving pieces and then it would work. Anyway, thank you for watching, listening, and see you on the next video. Bye.